Right, when it comes to the domain of surfaces, you don't need to know too much. You just need to be able to recognize which value should be excluded from the domain. So we have a surface equation here, z is equal to x over y. And what we just need to think is which values might you substitute in for x and y and potentially not get an output. Now, given that we got a fraction, you should be looking at the denominator, and the denominator is y. And what can't the value of the denominator of a fraction be? Well, it can't be 0. Okay, so we'd say that y cannot be equal to 0. That's the value we'd have to exclude in this scenario. So that's the main part on domain. However, sometimes in the AS papers, they're given the domain in terms of the modulus function, and potentially you might not have learnt that by the time the exam comes around. Okay, so let's just consider how we can rewrite these inequalities in a way that you're maybe more familiar with. So it says, what is another way of writing that the modulus of x is the same as a less than 2? Or you could say the magnitude of x. Now, what do we mean by the magnitude of x? We mean the distance from 0. So let's consider this on a number line. Let's write 0, and then we'll write 1, 2, 3, and I'll leave it there. Then -1, -2, -3, and we'll leave it there. Now I'm looking for all the values x such that the distance to 0 is the same as or less than 2. So for example, this point here, 1, well, the distance to 0 would just be 1. Okay, so that point would satisfy the inequality. Then for example, this point here, let's say that's 0.5. Well, that has a distance of 0.5, so that would also satisfy. And this point here at 2, well, that is a distance of 2 from the origin, from 0. Okay, so that would fit the inequality, and essentially any values from 2 down to 0 would work. Okay, so what I'm going to do, I'm just going to do a shaded circle there, thinking back to GCSE and inequalities and how we represent them on the number line. But remember, the distance to 0 is always going to be a positive value, even for our negative numbers. So if we take -1, for example, well, to 0, that has a distance of 1. Okay, so that would still fit the inequality. And the same can be said for -2. That would have a distance of 2 from 0. So therefore, all the points that satisfy the inequality would be anywhere between -2 and 2. So I could rewrite this inequality here as the following, which is perhaps a format you're more used to working with. Okay, so those two things mean the same. Now let's just transfer this to a more complex scenario. So you can see this time inside the modulus we've got x subtract 3. Well, if we look at the one we just did, what was in the modulus, we put it between 2 and -2 because we had a 2 over here. Well, let's deploy the same logic. We're going to write the x subtract 3 in the middle of our inequality, and then we'd have 2 and -2. Then we'd just rearrange to get x on its own. So we'd add 3, and add 3. So we'd get 1, and then on the other side we would get 5. Okay, and that is the rewritten version of that inequality. Now let's consider when we have a same as or greater than. Okay, so for the same as or greater than, what we're going to end up using for our x values is going to be all the ones outside of what I've drawn here. Okay, so it's going to be from the black circle onwards to the right, and then from the black circle onwards to the left, like that. Okay, so in terms of how I could express these as inequalities, if we start with the one on the right, okay, this would represent that x must be the same as or greater than 2, whereas the one on the left would represent that x must be the same as or less than -2. Okay, and I would stick or in the middle. Okay, because it can only be one or the other, it cannot be both at the same time. There's no such value that fits that criteria. Now finally, let's just make it a little bit more complicated again. Instead of having x here, okay, we've got x subtract 3. So to adapt the process, we're just going to replace the x's here with x subtract 3. So x subtract 3 is the same as or greater than 2, or x subtract 3 is the same as or less than -2. Now, if I rearrange my inequalities, if I add 3 to both sides, I get x is the same as or greater than 5, or x is the same as or less than positive 1. Okay, and that is how you would rewrite that inequality.